Okay, you guys, if you'll turn in your books to page 558, we're going to work on finding more angles and sides in triangles. And if you will recall, the first set of problems that we worked on solving for triangles, I told you that the law of sines was not the optimal method to use because remember, if we have an acute angle, let's say with the sine of a half, the obtuse angle will also have sine of 1/2. So we really don't know if it was referring to the acute angle or to the obtuse angle. With law of cosines, that's not the case because the obtuse angle has a positive, or excuse me, the acute angle has a positive cosine, and the obtuse angle has a negative cosine. So it's already built into the law of cosines to give you an obtuse angle if it is obtuse, or acute if it is acute. With the law of sines, it's not obvious. We don't know which it was. So it's called the ambiguous case, and that's what we're going to talk about today. So on page 558, it says given angle A is 40. Okay, so angle A is 40. Side A is 4. Remember, angle A and side A will be opposite each other. That's how you know how to place it. And C is 9. So this would be A. We could say this is B. And this is C. So C would be, side C would be across from angle C. Draw the triangle and solve for the values of the other side and angles. All right, so in this case, this is side B. What would we need to find first? Or what could we find first? We can't use the, let's see, we could use the law of cosines and find, no, we could find angle C using law of cosines. Okay, and that would give us angle C. We'd know whether it's obtuse or acute. So let's go ahead and do that. So it would be 9 squared. Oh, we can't use it because I can't find angle C if I don't know the other side. So we can't use law of cosines. So in order to find angle C, we'd need to use law of sines. So we could put 4 over sine of 40 equals 9 over sine of C. So 4 sine of C equals 9 sine of 40. Divide both sides by 4. So the sine of C, if I just type in this in my calculator, make sure you close that. So it'll look like this once you get it put in. Okay, hold on a minute. It's not liking this. Inverse sine. All right, so that is what it looks like. Let me just go ahead and show you so that if it comes to that, you don't freak out. Now, of course, if I got something like this, the first thing I would do is go back and check to make sure that I had entered my information in correctly. So I'm going to show you what I did put in. I put in exactly what we had on the paper, and it gave us an error, which is fine. That tells me simply that there is no such triangle with these values. So that's what you write. No such triangle. All right? So like I said, if you get that error message, go back and make sure you have it set up correctly. But if it gives it to you again, you know that you're good. There is no such triangle. So that was number 1. Let's look at number 2. Number 2 says draw the triangle and find the missing parts if angle A is 27, side A is 5, and B is 7. It doesn't matter if you put it down here or if you wanted to put it up here. It doesn't matter which you do. It's just an adjacent side. It's just all in the way you label the triangle then. Would be A. Since this is side B, that would be B, and this would be angle C. Okay, so again, we have a pair, so we can use the law of sines. We don't have enough information to use law of cosine, so we're going to go ahead and use law of sines, which will be 5 over the sine of 27 is equal to 7 over the sine of B. So cross multiply, 5 sine of B is equal to 7 sine of 27. Divide both sides by 5. And then B will be equal to the inverse sine of this. Make sure that you do put the parentheses that I'm showing you here, or you won't get the right answer. So I'm going to put in second sine of 7 sine 27, close the parentheses, divided by 5, close the parentheses again. All right, so let me show you what we get. We get 39.5. Okay? All right, so 39.5. The problem is, like I told you, because that gives us, that was a positive sign, it could be the angle that's up here at 39.5, but it also could be an obtuse angle with this being 39.5. And because it's the ambiguous case, I have to assume that both of them are going to work until I find out otherwise. So I'm going to say that B is 39.45. Oh, excuse me, that's supposed to be 5. Just 5. Yes. Or let's subtract 180 minus 39.5. Or B is equal to 140.5. Okay? So it could be either one. Which means we're going to have to find 2 different angles for C and 2 different sides for C. So we can find angle C now for each case, because 180 minus the sum of the other 2, which would be 39.5 plus 27. And then over here, angle C would be equal to 180 minus 140.5 plus 27. Now, here's where you'll know whether you actually have 2 triangles or not. If you add this right here, which I get 167.5, if you add these 2 and that's over 180, then you can't have a triangle because there would be no room for a third angle. So that's how you're going to know whether you have 1 triangle, 2 triangles, or as in the last case, it was no triangle because there wasn't a sign with that value. But right here is where you'll be able to tell if you're actually going to have 2 triangles. In this case, we are, because there are a few degrees left for this third angle. It's a tiny angle, but it's an angle anyway. So then here we have C is going to be equal to 180 minus 5, 7, 9, 16. So C will be equal to 113.5 or 12.5. So we do have 2 triangles. Now we have the sides that go with this. So we know that this is 12.5 or 113.5, which clearly my diagram doesn't show that, but it is either one of those. Angle B is 39.5 or 140.5. Okay. This is supposed to be just a 12 and it looks weird. All right, so set up law of sines to find the other side. So I'm going to say C over the sine of 12.5 equals B, or excuse me, 5 over the sine of 27. And over here, I'll say, actually, I wrote that the wrong way. I'm sorry, guys. It should be over here. C over the sine of 12.5 equals 5 over the sine of 27. And this one should be the other one, the 113.5, which is right on top of where I wrote the wrong information. So this will be C over sine of 113.5 equals 5 over sine 27. All right, so cross multiply, which will give me C sine of 27 equals 5 sine of 113.5. So then if we divide both sides by the sine of 27 and put that in the calculator, and when you do that, make sure that you put parentheses here. It's going to put one here. Make sure you close it. And then it's going to put a parentheses here. You can close it if you want or you don't have to. Okay, so you can find out what we get there. For the other triangle, when we cross multiply, we'll get C sine of 27. Same as what we have there. But when we cross multiply the other, it'll be 5 sine of 12.5. So we divide by sine of 27. All right, so let's put these in the calculator. So I have parentheses. Don't forget to put that first parentheses. 5 sine 113.5, close those parentheses, and close it again. And then divided by sine 27 equals. Okay, so I'll show you what we get for that. Right there. And that's what it's supposed to look like. Right, and we'll go back and do the other one. So that was 10.1. This one could actually just go up in my calculator. I'll show you guys how I'm doing this. If I go up in the calculator, hit enter, go up to this line to where it's green, bring it down again, and I can actually just go over and change the angle to what I need it to be, which was 12.5, I believe. Okay, and that way we don't have to enter the whole thing in again. Okay, so if we hit that, we get the value for the other value for C, which is 2.38. All right. So that is clearly an example of when the ambiguous case gives us two triangles. It won't always. If you get an error message and it says dim mismatch or something like that, then you know you can have no such triangle. All right, remember when you set it up, and you get to this point right here, this is going to tell you whether you have one triangle or two triangles. If the sum of these two angles is more than 180, then you're not going to have a third angle, which means you're only going to have one triangle, one possible triangle, all right? But you do have those possibilities, one triangle or two triangles. That's why it's called the ambiguous case. All right, thanks guys. Have a